Hi, I'm Kerry Hammil, a program manager on the Avalon team, and I'm going to talk today a little bit about the new 3D functionality that's been added to Avalon in the latest Community Technical Design preview. 3D is a really hot topic in Avalon right now. For one thing, the 3D functionality that's been added to Avalon is the last major new graphical feature area for Longhorn. There will be new features coming, new smaller features coming, for the remainder of the product cycle, but 3D is the last major new area of functionality that we're going to be adding. And so this is a really exciting release, given that this is the first time we're going to be releasing 3D for people to play with and to give us feedback on how we're doing. 3D has tremendous potential to enhance Avalon applications. Right now in Avalon, you can write applications that take advantage of a variety of 2D media, such as vector graphics, digital imaging, and video. But now, for the first time, application developers are going to have the opportunity to integrate 3D into the same application that uses all of these other media types. And we've provided a mechanism that will make that integration seamless and easy for an Avalon application developer to pick up. My goal in this talk today is to tell you a little bit about Avalon 3D, the types of features that it supports, and to give you the background information that you'll need to get started creating programs with Avalon 3D. On the agenda today, the first thing I'll do is describe the Avalon 3D vision. What are we trying to accomplish, and what are the main scenarios that we're trying to satisfy with the Avalon 3D library? I'll talk a little bit about how to use Avalon 3D. I'll walk you through a code sample that shows Avalon 3D in action. I'll talk about some of the exciting Avalon 3D features that are going to be coming in the future over the next few months. And finally, I'll show you some demos of Avalon 3D in action so that you can see some of the applications that have already been done using Avalon's 3D functionality in conjunction with the rest of the Avalon features. The Avalon 3D vision really has 4 parts. The first part to the vision is to enable productivity apps to move beyond the second dimension. Right now in Windows today, it's actually pretty difficult for an application developer to mix 3D and 2D content in the same application. And we want to remove that barrier so that productivity apps can start to explore some of the amazing 3D functionality that has been available to applications like games for years now. One good example of this is data visualization. There are many scenarios when visualizing a complex set of data where it makes sense to visualize that data using a 3-dimensional graph. But that's not something that's easy to accomplish in Windows today, and making that type of visualization possible is one example of what we want developers to be able to do with Avalon 3D. The second piece of the Avalon 3D vision is to provide an API that allows easy development of 3D UI effects. We want to make it so that you can add depth and other features of the third dimension to your user interface. So for instance, you could add a reflection to an icon, or you could have a small objects inside your UI, such as a button, that actually has shadows and highlights and other features that make it appear like it has depth and isn't just a flat 2D object that's put on the screen. The third piece of the Avalon 3D vision is to make it straightforward for developers to mix 3D content with other media types. This is really one of the major things that Avalon 3D is providing that hasn't been provided by other Windows APIs in the past. And finally, the fourth vision is to make it easy for developers to mix 3D content with other core platform features, such as terminal server, printing, accessibility, and multiple monitor support. The Avalon 3D functionality that you have in the Longhorn release you have in your hands right now will allow you to do many 3D things. Among these, as I mentioned, you can draw 3D content into the same window as other Avalon media types. So if you already have some Avalon applications that you've been working on, you can take those applications and start adding 3D functionality to them right now. Avalon 3D allows you to start basic. You can build a scene and add 3D meshes to it, 3D meshes representing the 3D objects that you want to display on the screen. You can add different kinds of lights to your scene. Some examples of the lights that we support are point lights, spotlights, and directional lights. And these different types of lights allow you to create different visual effects. For instance, a point light acts just like a light at the top of your room. It tends to light most objects in your scene equally and provides a general soft-looking light. However, a spotlight is a very dramatic lighting effect that can be applied to one object so that you can really highlight that object in relation to all of the other objects that are around it. Avalon 3D will also allow you to apply a variety of materials to your 3D objects. A material is the texture that is displayed on the surface of a 3D object in order to give it the appearance of having some sort of a physical texture on it. So you can start with a solid color material, which is the simplest, a constant color such as red or green. But you can also get more complicated and add an image as a material to a 3D object. You can take a 2D image file, load that using Avalon, and specify that as a brush to be used on your 3D object. You can also use various types of gradients, such as linear gradients and radial gradients, in order to create 3D objects that have interesting visual effects on their surfaces. Avalon 3D supports a fairly standard set of 3D transforms. You can scale, rotate, or translate any 3D objects. You can also group objects into collections of 3D meshes that can be transformed together so that you can make simple modeling operations easier to accomplish. And finally, Avalon 3D supports a general 4x4 matrix transform so that if you have a more complex transformation in mind, you can accomplish that. Avalon 3D currently includes support for hit testing 3D content, meaning that you can make your 3D meshes responsive to mouse input. A user can click on a 3D mesh and your application can respond to that mouse click. And finally, all of this functionality is available from both XAML and from managed code. So all of the things I've described here can be programmed via markup, as well as via C# or other languages supported by the .NET framework. The image that I'm showing you right now is a still shot from an Avalon 3D application that just shows how some of these Avalon 3D features work together to create an application. This particular image is a display of a stock ticker that has been mapped onto the inside of a 3D sphere. Behind the stock ticker text, you can see a cloudy texture that's there to give some interest to the image. And you can imagine in the real application, this stock ticker would be animating and giving the user live updated data, potentially even data bound to an actual source of stock data, so that the user can have a stock ticker display that's a little bit more interesting than the standard 2D display that we're very used to at this point. So it's important at this point, after I've told you a little bit about what Avalon 3D is, it's important for me to describe a little bit about what Avalon 3D is not. Avalon 3D is focused on some very specific scenarios and customers, the scenarios that I've described in the Avalon 3D features and vision section. Avalon 3D, however, is not a replacement for DirectX. It's not meant to replace DirectX as the way that developers write applications like 3D games or CAD applications. Avalon 3D is meant to complement DirectX by making it easier for application developers to quickly and easily get started writing 3D programs. It's also important to note that Avalon is not a 3D layout system. The types of 3D operations I've described will all work inside of a single 3D scene, but the Avalon layout system is still inherently a 2D system. The Avalon layout system does not have the concept of a z-coordinate or of depth. So when you're taking 2D Avalon controls and laying them out, you're still laying objects out in relation to one another in 2D and not in 3D, not in a full 3D space. All of these scenarios that I've described that I've said Avalon 3D is not trying to satisfy, they all have specific requirements in terms of perf or functionality that exceed the scope of what Avalon 3D is going to be able to provide in the Longhorn timeframe. So if you have questions about when it's appropriate to use Avalon 3D, when it's appropriate to use DirectX, we can give you a little bit of guidance on that point. It's never a cut and dried line, but there are certain things that if you want to do, you'll find Avalon 3D useful. For instance, if you want to integrate 3D seamlessly into an Avalon application that also contains 2D content and controls, then Avalon 3D is probably the right API choice for you. If platform features such as remote desktop and multi-mon are high priorities for you, Avalon 3D is an attractive choice because this functionality has been built into the API. whereas you have to do more work in DirectX in order to support features like Multimon. Finally, if you want to easily add 3D functionality without needing to learn everything about how the graphics hardware works, Avalon 3D is a good thing to investigate because Avalon has tried to abstract some of the intricacies of the graphics hardware so that you can get started with 3D functionality relatively quickly. On the other hand, you'll find DirectX to be useful if you want access to all of the features provided by the graphics hardware, including some of the more advanced, all of the latest features in DX10 and forthcoming versions of DX and so on. Those are reasons why you would want to use DirectX instead of Avalon 3D. Another reason why you might make that choice is if you need to have full control over how your scene is stored and managed in memory. If you have a very performance-intensive application, such as a CAD program, then you're probably going to want the deep level of control that DirectX provides you and that Avalon 3D has somewhat abstracted away. So that gives you a little bit of an idea about why you would choose one API versus the other. So let's get started looking at how to write an Avalon 3D application. You only need a few basic API objects beyond what you need to write a standard Avalon application. The first few objects that you need to learn about are, first, the viewport 3D, which is a surface that holds your 3D content. You need to know about the model 3D. Model 3D encapsulates the idea of a 3D mesh, which is a 3D object that you'll be rendering on screen. A camera describes where in 3D space the viewer of your application will be sitting, and that in turn describes which objects are visible and from what viewpoint the user will be seeing 3D meshes. You'll need a light so that you can actually see the objects that are in your scene. You'll need some brushes or some materials so that you can add interest to the surface of your 3D meshes. And finally, you'll probably be interested in the transform 3D object, which allows you to move, scale, rotate, or in other ways position your 3D objects within the 3D world. Now let's take a look at an Avalon 3D sample application that will illustrate to you how you can get started writing your own Avalon 3D applications. This sample will be available for download from MSDN later, so if you don't catch everything right now, then go check out the sample and you can follow along by yourself on the sample application on your own computer. In this sample application, the first thing that you'll notice is that there is a new namespace referenced at the top of the file. This version of Longhorn introduces the Media 3D namespace, which is Appear to Media, the media namespace right now, and this is where all of the Avalon 3D functionality can be found in terms of the API. In general, this application is it starts by creating a standard window application, and the first section of code that you'll see here initializes the usual window properties, setting the window's height, width, some text, and making the background be a solid white colored brush. Right after that, when we start creating 3D content, the first thing that we do is create a viewport 3D object where we'll place all of the other 3D meshes and lights and other objects as they're drawn on the screen. The construction of the viewport 3D is very simple. The constructor does not take any parameters. You simply declare that you want to construct a 3D object, and then you can start working with it. The first thing we're going to do is add a camera to the viewport 3D. In this sample, I'm using a camera called a perspective camera. And a perspective camera creates a standard perspective projection, which is very familiar to all of us. It's where parallel lines actually foreshorten as the viewer gets farther and farther down the z-axis. The perspective camera, it's very simple to initialize, starts with the point in space where the camera will be located. It starts with, the second parameter is the point that the camera is going to look at. And finally, there is a vector describing the up direction for a camera. These three parameters are needed to fully describe any camera in a 3D world. This particular camera has been placed about 5 units up the negative z-axis, looking down the z-axis, so looking straight ahead from the viewpoint of the viewer, and with the up vector pointing straight up. Finally, we define 45-degree field of view for the camera, which makes it simulate roughly what the human visual system sees when it looks at the world. Finally, the last two parameters that we set are a near and a far plane distance, which are parameters that help the Avalon 3D library know when it can clip objects out. So objects that are further away than 10 units, we're not going to draw them, because we've set a far plane that says that we don't care about anything that's further away than 10 units. So it's a nice performance optimization that allows us to disregard some content of the 3D scene if it doesn't need to be drawn. Now that we have a camera and a viewport, we want to add some meshes so that we can actually have some 3D content to view. The first step is to create an object called a mesh 3D. We're going to programmatically construct a triangle. The next several lines of code may look a little complex because what we're doing is creating a triangle by placing 3 points in space and then initializing other appropriate parameters. So I'll walk you through this fairly quickly, but this is not actually the core of the 3D functionality. So if you're interested, check it out in the sample on MSDN if you want to see a little bit more about the specific properties of the triangle. These 3 lines of code place the triangle in space, adding 3 coordinates to create the vertices of the triangle. And then after that, we initialize the normals of the mesh 3D. The normals are essential for the lighting process, and they basically describe which direction is perpendicularly out from each vertex of the triangle. Finally, we set up the texture coordinates that will describe how brushes are mapped onto the 3D mesh's surface. And we construct a model 3D object out of the triangle mesh that we've just defined programmatically. You'll notice in the model 3D constructor, we specify a brush material that is a red solid color brush. And that means this triangle is going to have a flat red surface when it's actually displayed on the screen. You could replace this with a number of different types of brushes, such as an image brush or a gradient brush, if you wanted to create a triangle that has a somewhat different look. The next thing this sample does is construct a sphere. And for this particular part of the sample, I've taken the construction of the sphere and put it into a separate place because it's really a little bit distracting from the actual working with the Avalon 3D logic. So if you download the sample, you'll be able to see how we programmatically constructed a sphere, and you can use that to create your own meshes if you'd like to work with spheres. Now that we have 2 objects, we have a sphere and a triangle, we're going to add some lights to the 3D scene. This section of the code creates several different lights, 3 of the different types of lights that Avalon 3D supports, so that you can see how the different lights look and how they affect the overall view of the scene. We construct an ambient light, which says it's basically a certain level of light that is applied to all objects in the scene. It's not a light with a source, it's truly just an ambient light that happens to be present everywhere. We create a directional light, which does have a point in space, and it also has a place that it's looking at. So it has both of those things to describe how the light is being projected. And finally, we create a point light, which, as I described before, acts something like the sun in the sky, where it has a point in space, but it's almost infinitely far away from the camera, so it tends to light all objects equally. So we have 3 lights that we can work with on our meshes that we've created. The next thing we're going to do before we actually go and display our meshes on screen is set up several transforms so that we can position and manipulate the locations of the 3D meshes. There are 3 different types of 3D transforms, like I mentioned earlier, the translate, the scale, and the rotate transform. And this sample creates one of each so that you can see what it looks like to create these transforms and apply them to a mesh. The application of the transform is very simple. Transform is a property on the model 3D, and you can set the transform property to any one of the transforms that we've created. I'm leaving that commented out right now so that when we first run the sample, you'll see what the triangle looks like without a transform. Then we'll come back and we'll show you what it looks like with the transform. So finally, we've gone through the process of constructing all of our basic 3D objects, and now we can start adding them to the viewport 3D that we created at the beginning of the sample. First, we add the camera. Next, we add the light, the triangle, and the sphere that we created. And then finally, the last line of this sample simply makes the viewport 3D visible by adding it to the Windows content property. So now that we've done all of that, you've seen all of the basic structure that's necessary to create an Avalon 3D application. Let us build and run this application using the MS Build tool that's available with the SDK. After the sample is built, we run it and we see we have a sphere and a triangle, both sitting in space, lit with the light that's coming from the upper left portion of the screen. So that's how you start building a basic 3D application in Avalon. Now that you have the basic structure, it's pretty easy to make simple changes, such as applying that transform to the triangle. In order to apply that transform, I'll comment out the transform that I discussed recently, save the sample, rebuild it, and then run it again. And you'll see that the triangle is now rotated in 3D space, looking like it's been rotated 45 degrees away from the user. Finally, I will show you the effect of some of the other types of lights. If you'll recall, we defined 3 different types of lights: an ambient, a directional, and a point light. And the sample I just showed you running used the directional light. Let's change it so it uses the point light now. In order to do that, all I have to do is change which light I'm adding to my viewport 3D, save the sample, build it, and run it again. And now you'll see that the scene looks somewhat different because it's got a different type of light applied to it. So this is an example of how you can use Avalon 3D and get started adding 3D content to your own applications. Now I'm going to tell you a little bit about Avalon 3D features that are coming soon. These features aren't included in the release of Longhorn that you have right now, but they're features that we're working on right now and will be included in future releases. The first new feature we're working on is better support for 3D brushes. We're going to add support for tile, wrap, and clamp modes like you have in 2D brushes today, so that really anything you can do with a 2D brush, you can also do with a 3D brush. We're also going to work on some fixes for bugs you might run into when you use a brush on a 3D object with a very large scale factor. So right now, if you use a 2D brush and you apply it to a 3D mesh, and your texture coordinates are set up such that there's a very large scale transform applied to the brush, you may see things like blockiness in the material when it's eventually displayed on your 3D object. We're working on methods that will allow us to more intelligently guess the scale factor we should use for rasterizing the brush so that you don't have to worry about doing that yourself. Future releases of Avalon 3D will also include independent animation for 3D objects. The Avalon 3D functionality is very closely tied in with the animation system that you have right now for Avalon 2D objects. So you'll be able to set up and run animations on your 3D meshes. You'll be able to animate transforms, the brushes that you're applying to your objects, and any other 3D properties such as the camera of the location that you can animate. A future release of Avalon 3D will include per-primitive anti-aliasing for 3D. Per-primitive anti-aliasing is interesting because not all 3D cards support full scene anti-aliasing. This feature will allow you to have smooth anti-aliased content no matter what graphics hardware your user is running. We will be adding a constant width line primitive, which is interesting if you want to build bounding boxes around 3D objects. Because a bounding box, you want to appear to be the same width even as the bounding box line disappears off into Z-space. You don't want that line to be foreshortened. So we're building a feature, a line primitive, that will make it easier for you to do bounding boxes around 3D meshes. And finally, we will allow you to apply specular, diffuse, and ambient color properties for mesh materials, so that you can have all 3 materials instead of just one applied to each 3D object. More Avalon 3D features coming soon include the ability to integrate any 2D Avalon content into a 3D scene via visual material. This particular feature is interesting because it allows you to take any 2D visual object and map it as a texture onto a 3D mesh. And the 2D content can still be live. So for instance, you might take an Avalon button object and apply that button as a texture onto a sphere. And your button will continue to update itself on the sphere as for instance, if the user hovers over it and you've coded the button so that the button changes colors when it's being hovered over, that input and that response will still work correctly even though the button is mapped onto a 3D mesh. The user can even click the button and have the button do what it's supposed to do, even as it's mapped onto a 3D mesh in a 3D world. So now I'm going to switch over and I'm going to show you some demonstrations of Avalon applications that have taken advantage of 3D to add depth to an inherently 2D application. The first example I'm going to show you is a live version of the same sort of stock ticker application that I showed you that was a still in the slides before. What this application does is it takes Microsoft's WinHEC logo, maps it onto the inside of a sphere, and animates it. This particular application is showing you the inside of the sphere from 4 different viewpoints so that you can get an idea for how the location of the camera affects what the user will see. You'll also notice there's an interesting animating cloud texture in the background that was also created with Avalon 3D. This was created by having several different brushes, some of which are semi-transparent, layered on top of one another and animating those brushes. So this is an example of how you can create some very stunning visual effects using Avalon 3D's capabilities. The next application I'm going to show is a simulation of an online video game shopping application. This particular application is allowing you to browse through and purchase Xbox games. So some 3D features you'll see right off the bat are reflection at the bottom of the screen of all of the game objects that you see on the application. You'll also notice that as the user mouses over different selections, the game titles flip forward using a 3D rotation in order to present the user with a full-on view of whatever application they're hovering over at the moment. And finally, when the user selects an application, there is a nice transition animation applied to the large view of the game on the left-hand side of the screen so that the user can see the game that they're currently browsing. So this application has taken Avalon 3D functionality and it's actually created ways to enhance an application that's normally written in 2D. I mean, this is an example of how you can take Avalon 3D and enhance an application that would normally have been probably rather flat and not have had a lot of depth to it. And finally, the third application that I'm going to show demonstrates data visualization in an Avalon application using the third dimension to better envision different data variables in relation to one another. This application simulates graphing different patients' blood sugar levels over time. So you can see there are 4 different patients, and the application allows you to select one or multiple sets of data to view at the same time. Because there are 3 different variables that we're viewing right now, it's very handy to be able to create a 3D graph so that all of these different variables can be viewed in relation to one another at the same time. And finally, Avalon 3D animation features allow you to make the camera slowly rotate so that you can view the data from different angles and perhaps see data trends that you wouldn't be able to see from just a single viewpoint. So these are some examples of ways that Avalon 3D applications have been able to take advantage of the functionality that's been added to Avalon in terms of 3D functionality. In summary, check out the new Avalon 3D features that are included in the latest Community Technical Preview of Longhorn. Please give us feedback in the news groups. If you run into questions or issues, or if you have feature requests, we would love to hear it. Since this is the first time that we've made this 3D functionality publicly available, we're eager to hear how you're using it and if you have any questions or issues about it. And finally, there are some resources you can use to learn a little bit more about Avalon and Longhorn. An MSDN site where you can read about latest developments in Longhorn, an online version of the SDK where you can read about Avalon 3D and many other features. And finally, you can check out Channel 9, which is a place where you can read blogs from Microsoft employees and from users of Longhorn and Avalon. And you can even ask questions and discuss what you're doing with other developers. Thank you very much. I hope that you enjoyed this presentation and have a wonderful time writing Avalon 3D applications.